Hi, this is Ashisha Bidekar, and welcome to my podcast, The ARB Show. I'm thrilled to introduce today's guest, Prateek. Prateek is a passionate innovator and an engineer. He has worked with global MNCs like Rolls Royce and John Deere. He's the co founder of DG Propulsion, which has designed, built, and tested India's first indigenous jet engines. DG Propulsion is a cutting edge manufacturer of advanced aerospace technologies, specializing in the development of jet engines, gas turbines, jet speeders, and air taxis. Prateek has four patents for his innovation in gas turbines and fuel cells. Welcome to the show, Prateek. Look forward to hearing your views on top five trends in jet engines for UAVs. Over to you.
Hi, Ashish. Thanks for this opportunity. Uh, I'm all about jet engines. I would quickly go back slightly, and I'll try to keep it really simple so that any layman can understand as well what's been going on and what we are doing. So this whole thing started back in 2013 when I was still in college, and you know it had a very humble beginning. It was a school project, as you can call it, or a college project. And we quickly realized that while we were still looking around for options, where to get the parts from, where to get the manufacturing done, that there is essentially no ecosystem in India, or there is, I wouldn't say no, but there is very less accessible ecosystem in India to get these kind of parts and get any sort of turbine technology. It's not available to normal people. So we sort of understood that there is a gap in the market, and definitely India will at some point need their own jet propulsion technology as well, since a whole lot of this tech is being imported right now as well. So I kept on working. I kept on developing, small jet engines. Initially started with turbocharger-based jet engines, and then slowly climbed my way up to make actual working miniature gas turbines. Then I met my co-founder, Mr. Chirag Gupta. He's ex-Navy. We met in through some of our common contacts in Indian Air Force. Uh, we met in 2018, and then we formed this company called DG Propulsion in 2019. D is for my last name, Dhawan. G is for his last name, Gupta. So it's simple as well. So DG Propulsion was incorporated in 2019. We started developing small to medium-sized jet engines for UAVs, starting from 40 kilogram thrust all the way up to 150 kilogram thrust. The way we have developed these products is they are easily scalable down and up. So we can essentially use the same designs and then scale them up, essentially keeping a lot of other things constant. And then we realized that we need control systems to control these jet engines because they have to be autonomously controlled during flight. So there was very few suppliers who could support us, and they were asking for exorbitant amount of money to develop the controller for these jet engines. So we had to develop our own controller as well. So now today we have our jet engines and we have our own control system for the jet engine. So this is not so short background on what I am doing and what DG Propulsion does. So regarding top five trends, so I think the biggest thing can be attributed to the Make in India initiative that was started by our government many years ago. So what that did was that propelled that sense of that we have to at least try to make a lot of things here in India itself. So we were already doing it. Make in India came into the picture, and that sort of encouraged us quite a bit to start making and start developing these jet engines in India. So by 2022, 23, we already had built an ecosystem that was supporting us to get the right precision machining done that's needed for these jet engines to source the right parts, the right metallurgy. So I think number one trend, as anyone would know by now, is the Make in India thing that's happening. So that sense of indigenous development and self-reliance. So that is the number one.
Got it. So here, just
Yeah.
on that same point, so essentially, because the government is the biggest, is the only buyer for defense-related stuff, and if you do indigenization of many of these, equipment, then that's a substantial saving in the foreign exchange, right? So there are multiple benefits from a financial perspective as well as for employment and business, right? Because like what you're doing, you scale up the kind of employment and the skill increase, or the skilled pool required for such industries also increase. So there's a primary and a secondary benefit which I see from this perspective. Excellent.
Of course, yeah, there is a huge benefit when it comes to manufacturing these. Of course, I mean there is a big economic impact. You start creating jobs. Like I need test engineers for testing these jet engines. We need more manufacturing jobs as well. So make in India for if you just take into account the jet propulsion technology, the number one thing is all of these engines are being imported. So of course they will be expensive, and of course the country who is selling these engines to India, they control the supply. They can say no at a given point. Let's say I don't want to bring in the war thing, but let's say something is going on in the geopolitical scenario, and then you have seen what happens when the big countries, they control the supply, and they can at any point say or delay that, okay, no, we are not giving you this technology right now. So that is number one thing that we have seen, and we are trying to fill that gap. And like I said, I mean, these jet engines are for UAVs, and for UAVs, the government is the biggest customer right now. So yes, we are supporting our government by developing them in-house in India.
Yeah. Great. So what are some of the other trends which you would like to share with the audience?
So some of the other trends regarding the metallurgy. So many people have asked me over the years that, how are you able to make this metallurgy in India? How are you able to make the single crystal turbine blades in India? I just want to clean the air here. Single crystal turbine blades are not used in these single stage micro turbojet engines. We don't need that. We are not asking for that. Those things are needed for much bigger, much higher power class jet engines. We are not developing them as yet. And that is probably one of the reasons we are able to do that in India right now, because we don't need all those fancy technologies at the moment. And I think there is a gap, there is a mental gap that I see a lot of times and I'm putting it out here. If any entrepreneur is listening to me, whenever you enter a manufacturing business or a business of this kind, don't carry that luggage with you ki, hey, we will need these fancy technologies and wo to yahan pe hai nahi, to, how will we do it? It's not that. We will start with something small. Jet engines, they are not being built up to that scale in India. So if we bring in the fancy technology, we won't be able to do anything, right? I mean, we cannot start with making a Rolls Royce, number one. You have to start with Maruti Suzuki at some point. So that is what we are doing. We are essentially in the business of making Maruti of the jet engines in India. So and they work perfectly nicely. So the trend is metallurgy, questions about metallurgy. We will climb that ladder slowly, and we have suppliers who are actually actively building these metallurgies and these special nickel alloys here in India, and we will be using them slowly as we go down the line.
Got it. So also, that's a very valid point that, you can't boil an ocean, as they say, right? So start small and progressively scale up. And I'm sure even for your small micro, kind of jet engines, you have customers, right? Paying customers from the defense forces or the government or so. And that's kind of giving you adequate ramp up to kind of go up the value chain as well.
So another thing regarding what our government is doing, and that's really nice, they have many grant opportunities. IDEX is one of them. IDEX is Innovation for Defense Excellence. So it was started by the central government, I think, many years ago. So we applied for that and we got selected in through the ITEX program for development of indigenous jet engines again. So yeah, there are a lot of grant opportunities, and they really help startups like ours, which are not so big startups. The thing is, what grants do is they will give you this uh, initial sort of, what do you call it, some buffer period to actually start building something right now, and then eventually you get into the funding headache and all, like going to the VCs, going to the angel investors. So I think the third trend which I can probably comment at this right now is a lot of VCs and a lot of funding opportunities are coming in the deep tech space as well. I still think, and it's just my opinion, that it's in a very nascent stage. Uh, a lot of these investors and these VCs, they are still coming out of that era where the service-based businesses were before, like you see Zomato, Swiggy, Flipkart. So these were all e-commerce businesses. So they are slowly coming out of that thought process and starting to invest in deep tech space. I mean, you have really brilliant startups like no longer startups, but companies like Skyroot Aerospace, like all of these rocket manufacturing companies. So yeah, that thing is again really impressive that we as a country, including the investors, we are slowly moving towards more deep tech and more manufacturing environment.
Got it. But when you talk of investor, and specifically in a sector like yours, where a deep understanding of the either technology or appreciation of the technology, and a kind of a foresight to see, okay, this is what would happen in the next 5 years, 10 years or so. Because of D2C or consumer internet related startups, it's very easy for VCs to create or form a thesis, right? Saying that, okay, this is what it is. This is how, say, a Zomato has done. So someone like this is what they expect this sector to do, and hence they kind of chase that. Do you still feel that for the sector, like the deep tech or defense related stuff, there needs to be more kind of education or awareness for the general public as well as investors as to how this sector is different, how it is separate compared to the other tech related stuff? Maybe you can throw some light on that as well.
Absolutely. I mean, what you have said, I cannot agree enough on this thing. Everyone has to understand deep tech startups are different. I mean, the thing with direct to customer startups is it appears really cool, right? I mean, everyone wants to make a Facebook again. Facebook is as much as you can get close to the customer, right? But the thing is, there's money in it, and of course, investors are in this for the money. And with the D2C startups, it's easy to see the growth, and the more the customer, right, you sort of can relate that more the number of customers is sort of proportional to the growth you will see. So they have these theses that they have already built from the D2C startups that get rich quickly kind of a thing. So that does not happen with deep tech startups. Let's say for a manufacturing startup, you have to have certain real estate or certain capex for basic manufacturing, right? You have to have certain specialized machinery like metal 3D printer, 5-axis CNC machines. You have to have at least these kind of machinery to begin with, and that's where most of the money. And these things are really expensive. It's not like you form a team and make the software and off you go start selling. It does not happen. It simply does not happen in a deep tech startup. And you can take examples from all across the world as well. How many rockets they crashed before SpaceX was able to do it for the first time. I mean, they were almost about to go bankrupt at some point, right? After spending millions of dollars. So that's the kind of investment that's needed in this. And that calls for a very focused and specialized thinking from the investor standpoint as well, that they should be aligned. That, okay, this is the waiting period, this is where they have to put in the money, and the returns come in later. And we at DG Propulsion, we are in for the long run. We are not chasing, okay, you put in the money today or 5 saal mein paisa double kind of a thing. That's not happening. That is a recipe for a disaster. If you come into a deep tech startup with this mentality, you're gonna fail.
Got it. So what you require is what they call as patient capital.
I think that's what they call it.
True. Yeah. And other thing, just thinking aloud, are there any initiatives from the government, specifically from the manufacturing or the deep tech area, wherein many of the common requirements from a manufacturing perspective, for example, let's say specialized 3D printing, special metallurgy, or overall things which could be common, right? Which could be common for, say, defense related or manufacturing related startup. And let's say if there are industry parks, or let's say if there are specialized organizations, right, wherein you kind of do this. Will that help to kind of foster innovation and bring in more startups? Because I'm trying to draw a parallel between, say, accelerators or similar things, wherein they give all the software or the other elements which are typical cost, right? For example, you've got sitting space, right? You've got common facilities, you've got cloud credits, you've got other stuff which kind of reduce the entry barrier for that. Similarly, are there any initiatives like that from a manufacturing perspective?
So, we have a lot of incubators in India. Almost all of the IITs, they have their own incubators. I know IIT Delhi has a really good incubator. They have incubated very similar startups like ours. IIT Madras, they are probably leading the way here. They have big combustion lab that is directly linked to what we do at DG Propulsion, and they have incubated some really nice startups as well. I know quite a few founders who are incubated in IIT Madras. So yes, they have these facilities. But the thing is, just having this is not enough. I think the entrepreneurs who have to enter the deep tech startup, they should have a good background in this as well, because having a piece of machinery is just one part of the puzzle, one piece of the puzzle, right? You have to understand how to efficiently use that machinery to your needs. For example, metal 3D printing. So everyone wants to use the latest technology. That is kind of a thing I have seen in especially the Indian maker space, that something that you hear is cool, you want to use that. Ki metal 3D printing use karenge, this is gonna change everything, because this is the latest technology. But the thing is, you have to look deeper if that is saving you money, if that is making your process more efficient. Now the thing is, I will slightly deviate and go to the rocket manufacturing industry, how rocket engines are made. They were in the earlier times, not so long ago, probably 10 years ago, these things, especially the combustion chambers of the rocket and the nozzles, because they have to be regeneratively cooled, they were made through the legacy process like brazing and stuff. And that was really, really, really time consuming, lot of laborious task. बहुत time लगता था उसमें, बहुत labor लगती थी. So it was very expensive. Metal 3D printing came along, and that was like the best thing that ever happened to the rocket industry. Now, all of a sudden, you will see, and you are seeing actually, a lot of these small rocket startups have come up, right, in India as well and internationally as well. Everybody wants to make rocket engines now. And that's probably in some part being attributed to how the industry is moving towards low cost and reusable rockets, and because the technologies like metal 3D printing are coming along as well. Whereas just because one technology is a very good fit for one industry does not necessarily mean it is good fit for all of the industries as well. Like in our case, making the hot section components. So yes, we are using metal 3D printers for some static hot section components, but the dynamic components like the turbine wheel, it's not making a lot of sense for me right now to use metal 3D printing in that. And trust me, I've worked with the best of the best suppliers who actually introduced metal 3D printing to the world. We have met with them, we have talked to them, we have given them our requirements, and they have come back to us that this is your costing that look like, all the risk is yours, You pay the money, you are responsible if something fails. So, this is not how things work. So that is where the gap is still. So we are not chasing what's cool, we are chasing what is functional, we are chasing what is practical.
Got it. A slight deviation when you talk of jet engines, and specifically what you are focusing is on the UAVs. Can you kind of highlight, give more focus on this specific requirements of how the UAV or the kind of drone related areas is different from a regular fighter jets or aircraft, aerospace? How are the jet engines different? Maybe that can also help the audience to understand the nuances.
I'll probably make two important points on this. That's a really good question. One is how these jet engines are different from the ones used in, I would say, manned applications or bigger applications like the fighter jets. And number two, how the scenario of the warfare is changing and why these jet engines right now. First thing first, bigger engines used in fighter aircrafts and in passenger aircrafts, they are human rated engines. Because the aircraft is flying, there is a human on board or multiple humans on board. So the reliability on those engines is totally different. The acceptance criteria, as you would want to say. Whereas our jet engines, they are for the unmanned applications as of now. So we are not too much concerned if this thing goes down, anything bad will happen to anyone's life, right? So this is number one thing that's different. Number two, after a certain point, after a certain thrust rating, you have to get into turbofan kind of a jet engine. So turbofan, it's a whole different topic, but for the sake of this discussion, I'll keep it really simple. You have a big fan at the inlet of the jet engine, and you use some of that air, probably 10%, depending on what the bypass ratio is, for the combustion needs, and rest of the air is bypassed through the engine, and it's just used as for the thrust purposes. And it dramatically increases the efficiency. When you say efficiency, specific fuel consumption. For a given amount of thrust, how much fuel you are using. Turbofans, they have a really good specific fuel consumption. And those things are challenging. You have multi-rotors, you have to support this big fan, you have to power that big fan, you need multiple compressor stages, you need multiple turbine stages. It's a different beast altogether. Whereas, for the smaller engines, you don't need that kind of complexity. Ours are single stage engines, one compressor, one turbine, that's it. Keep the thing simple, that will bring the cost down. And why do you need low cost? I'll come to my second point. So we have all seen what's happening around the world in Europe, in Middle East, right? Low cost warfare is the future. Instead of sending one person on a fighter airplane, I mean, I'm sure there are mission needs for that as well. I'm not intending that that's going out of the scenario anytime soon. But instead of sending the pilot, a human, like that is the most important resource anywhere, you send a lot of these low-cost drones, or you would like to call them low-cost cruise missiles. So you just shot them from the safest distance. आप अपनी country से you can shoot them, and then they'll cruise along, and then you drop them whenever you want them to do the job. So that is where the modern warfare is moving towards. Low-cost drones, low-cost expendable drones. And that's why one of the most, one of the most expensive components in these drones or low-cost cruise missiles is the propulsion system. And if you bring the cost of the propulsion system down, automatically the cost of the cruise missile, it comes down as well. So that's why we are into this low-cost jet propulsion.
Got it. So also they use the term, I think it's called swarm warfare, if I recollect correctly, wherein you've got multitude of drones, working in unison at the same time. Just on that point, are you focusing only on defense areas, or are looking at commercial and civil kind of applications for your propulsion? And finally, what's the kind of drone market you're trying to address?
So, whenever we send out any engine, we don't label it that it's only for defense or it's only for this use. We are open to selling to anyone, right? It's not just for defense, but it just happens to be the case that defense is the biggest customer right now. But we are also seeing interest in other spaces, other commercial spaces as well, like hovercrafts, air taxis, right? A short range air taxi, like probably for the ride of anywhere around 30 to 40 minutes, where battery powered impellers or battery powered propellers can't do enough of the job because power density is still the thing. You cannot still compete with the power density of, for example, a jet engine. So we are catering that market as well.
Got it. Got it. So let's go to the other trends or other points which you would like to address.
So I think other trend that I'm seeing, I touched upon it a little bit just right now as well, that control systems. When you talk about these technologies, jet engines, drones, swarm technologies, autonomous vehicles, you want to have really reliable control systems. And what I've seen over the years is we still lack that kind of expertise, to build these control systems in India. And that just not only the control systems, the associated hardware as well, like the PCBs that's needed, the microprocessors needed. So we still have to import a lot of these. So I think manufacturing your own control system gives you the edge over your competitors because you can really, really fine tune your own control system to your own need. And once you have your own control system, it's really easy to get into these expandable swarm drones kind of a thing. So I think control systems is one of the big challenges as well that we have faced over the years for our propulsion systems.
Got it. So what would be your final trend which you would like to share?
So I think final trend, and I think that's probably from my side the call of action as well, is we need to have more collaborative opportunities between government, between the institutions, and between the different startups. The more and more collaborative opportunity, there is no lack of experts in India. Let me put that out in the open. There are many experts. I mean, look at HAL. They are bunch of really nice and expert people in their domain. I mean, look at GTRE, look at DRDO. These people are phenomenal in what they are doing. And we need more collaborative opportunities with them. And we need that sense of getting the things done. Rather than, just keeping on doing these simulations on the system, we have to actually make the product. I think that's what I've seen during my education years in US as well, that we still lack to some extent this sense of actually getting the hands dirty, getting your feet wet. We enjoy doing simulations more than we actually enjoy making something, getting our hands dirty, and then seeing it fail and then iterating over that.
Got it. Also, I think failure is an important step towards success. And what you mentioned about SpaceX is a very valid point, right? I mean, they had so many numerous failures before it started making success, and it's only now that you see them being successful. To that extent, even I think there's a manned mission in the space, and to bring the astronauts back, it's going to be SpaceX and not Boeing, which has been a kind of a legacy player in this area. So that's very interesting.
Yeah. And I think one point, when I say making something and failing, definitely I'm not intending towards making something that is again human rated, right? I'm not implying that. For that, you need to have more and more data as much as you can. Like, if you look at SpaceX, they did not start sending humans like till a very few years ago, right? Before that, they did a lot of unmanned missions, and then probably after lot of data collection, lot of testing, lot of simulations, finally they were comfortable. Okay, yeah, we can probably start sending humans to space, right? So one of my professors, he very jokingly used to say CFD, which is computational fluid dynamics. He used to call it colorful fluid dynamics because of the kind of colors that show on your reports and all. So I'm not saying CFD and any of these tools, they are not important. They are really important. They give you one of the best, some of the best insights. But in all of the companies that I have worked for, they will never stop at CFD. They will test the actual product, and the product will fail in the prototype stage, and then they will build upon. So I think we sort of stop at this first stage. We just keep on iterating in our simulations. And I think whenever it comes to the execution point or the actual building point, or maybe building your MVP or sort of like that in hardware startups, we still lack that mentality, I guess.
Got it. Excellent. Thanks, Prateek. This gives a great perspective. And thank you, dear listeners, for tuning in. Do subscribe, share, and like this podcast. Consider giving it a 5-star rating if you like the content. Bye for now. Talk to you soon.